Okay, we've already been practicing for a couple weeks dividing by one-digit divisor to really make sure that we are doing well with the division process steps. Can y'all remind me what our steps are? They're over here if you forget.
Divide, multiply, subtract, bring down.
Good. Divide, multiply, subtract, bring down, repeat. Okay? Same steps apply today. The only difference is now we have 2 digits in our divisor. Before we start, I want to remind you, because you really need to know, especially now, that this number inside the division box is called the dividend. The number outside the division box is called the divisor. Does anybody know what we write on the top? What is that called?
Quotient.
Quotient. Very good. So up here on top is our quotient. It's the answer to a division problem. Okay, so the first thing that you need to do is ask yourself, can the divisor, outside number, be divided into the first 2 digits of the dividend? It is a 2-digit divisor. That's why I'm saying the first 2 digits of the dividend. If yes, we'll go to step 2. If no, we place 0, the hero, in the quotient above the second digit in the dividend. So what does this look like? It would be like if I had, for example, a 12 in my divisor, and then I had 1, 0, 7, 2. Okay? So I know obviously 12 can't just go into one digit. That's why step 1 says, can the divisor be divided into the first 2 digits?
No.
It cannot. So if it was yes, I would go immediately down here to step 2, but because my answer is no to that first step question, I have to put 0, the hero, above the second digit in my, it's not writing. Sorry, hold on. What? There we go. I want 0, the hero, right here. Can I put 0, the hero, above the 1 also? Yeah, I can. The important thing, and I'm sure that you've already realized how important it is to keep everything lined up. The important thing to do is to put 0, the hero, above that second digit so you don't accidentally misalign your answer. Okay? All right. Now what I'm looking at is I want to see, okay, so if 12 can't go into 10, then I need to go on to step 2. So step 2 says determine how many times the divisor goes into the first 3 digits of the dividend. So now I'm not just looking at 12 into 10, I'm looking at how many times can 12 can go into 107. So how many groups of 12 can I make out of 107? Anybody know? 8. If I did 9, what's 12 times 9? 108. That's too much. So I can only make 8 groups of 12 out of 107, which is 96. I did the multiplication part. Then I would do the subtraction part. And I'm not going to keep going because step 3 basically just tells me use the process steps for division. Okay, I only wrote this part right here just to kind of show you what I was talking about here in step 1, if yes or if no. All right, let's do one completely as an example together. So come down here, we're gonna write down our process steps. So we have divide, you guys just told me. Divide, multiply, subtract, and bring down. And I accidentally drew this wrong. This D should be here. And so we're going to turn this into a bring down. And I left off the R, repeat, but we know that we have to repeat our steps over and over and over until we're done. All right, so on the very first one that I wrote out, I went ahead and kind of did some steps that go with it, just to kind of guide us. So first, can 47, my divisor, divide into 36, the first two digits? No. So then I go and I have to ask myself, okay, well, then how many times does 47 go into 365? Okay, that's hard, right? Okay, but it's not too hard. So here's one thing that I like to do to figure out how many times 47 goes into 365. Once you get double digits in your divisor, your numbers automatically are just bigger. Okay, we're no longer working with single digits, basic math facts. We now have bigger numbers. Anytime you are trying to solve a problem in your head, you typically use estimation, right? You like estimate you round the numbers so they're easier to work with. So I use what we call compatible numbers. What does compatible mean? Anybody know? Easy to work with each other. What else? Not necessarily the same. They what? They kind of go together, okay? I broke out in song in the first class. Have y'all ever seen Grease?
Yes.
Have you ever seen Pets? They go together like ram-a-lam-lam, a ding-a-ding-a-ding-dong. Okay, so every time you see the word compatible, start singing that song in your head. They go together like ram-a-lam-lam, a ding-a-ding-a-ding-dong. No? Okay, anyway. Okay, so you're going to use compatible numbers to help you. This might not help you because compatible numbers might be a difficult concept at this point, and that's okay. I'm going to show you something else you can do in a little bit. So after we do this, if you're like, wow, I don't get it, that's hard, that doesn't make sense, I'm going to show you something else you can do too. Okay, so compatible numbers just mean make the numbers easier to work with by rounding them so that they are friendly numbers. So 47 would go to 50. I would round 365 to 350. Anybody know why?
Because 5 goes up.
Okay, because I can evenly divide. Pretend like I don't have a 0 here or a 0 here. I know that 5 goes into 35 7 times. So 50 goes into 350 7 times. So that means I want to try 47 times 7 because 50 goes into 350 7 times. If I'm just estimating, trying to figure out what I would multiply 47 by to get a number close to 365, I used compatible numbers to land at 7. Now I'm going to actually multiply 47. Ooh, I don't want to do it there. I'm going to do 47 times 7 and see what I get. And I got 329. Will that work?
Yes.
It will. If I added 47 to 329, that's going to be too much. So I'm going to go ahead and mark my placeholder here so I make sure I put the 7 in the correct spot. 7 goes above the 5 because I divided 47 into 365 7 whole times. Now I multiply. 47 times 7 was what? 329. Now I subtract. It does require some borrowing and some regrouping. You should have 36 left over. And then what's the B stand for after I subtract? Bring down. So now, remember yesterday I told you that you could almost like redraw yourself a new division problem if you wanted to. And I repeat my steps. I divide 47 into 364. Well, if it only goes into 365 7 times, I know it only goes into 364
6 times 7.
also 7 times. Because I know that 47 times 7 is 329. So I'm doing the same thing. This time when I subtract, I have 35 left over. So that would be my remainder. So my answer is 77, remainder 35. I need to finish filling in my notes over here too because I did it up here in my problem. would circle yes. Okay, let's go to the next page. We're gonna do lots of practice. I'm gonna show you another way not using compatible numbers. And honestly, guys, this is what I did for years because compatible numbers didn't make sense to me right at first. I didn't get it. So this is what my paper looked like a lot when I was in school. Okay, first, I know 72 can't go into 2. I know 72 can't go into 22. I know it can go into 227. I just have no clue how many times. I don't get compatible numbers. That doesn't make sense to me. So I'm going to start right in the middle, and I'm just going to try 72 times 5. Why do you think I would do times 5 and not like times 7 first? Because it's what? Yeah, okay, first of all, multiplying anything by 5 is pretty easy. Okay, and it's also right in the middle. So I know that I have to have a single digit that goes up here. So if I start at 5, it's right in the middle. If it's too high, I know it's got to be less than 5. If it's too low, I know that this number has to be greater than 5. And maybe 5 works, I don't know. But this is what I did literally every time. I had all these little bitty multiplication problems all over my paper because I would start at 5 every time. Okay, so 72 times 5 is 10, and that makes 360. So am I way too high? I am a little bit high. So I'm going to say if I took 72 away from that, it's probably still going to be too big. So I'm going to try 72 times 3 instead. It still might be too big, but I know it's going to be closer.
216.
Now, will that work?
Yes.
Yes, so I'm going to put a 3 up here. I've already done the multiplication part, so I'm just going to write 216 underneath. But now I need to subtract. Divide, multiply, subtract, bring down. Divide, multiply, subtract. I have 11 left over, bring down. That makes that 115. Now, if I think about this for a minute, I already know 72 times 3 is 216, so that's way too much. If I did 72 times 2, I'm doubling it. Okay, so there'd be like 2 72s. That's too much. So what do I put in my quotient? If 2 is too much, what goes in my, 1 right here. And then 72 times 1 is 72. And then I subtract, because I divide, I multiply, now I subtract. And this leaves me with 43. So my remainder is 43. So my final answer for this one is 31, remainder 43. Okay, we're going to do another one together. If you feel like you get this and you want to go on and just check, like after I'm done, that's fine. You can work ahead of me and go back and check. If you want to stay with me, we're going to keep going. Okay, the next one is 3,862 divided by 56. I know 56 cannot go into 3, and I know that it cannot go into 38. I know it can go into 386, I just don't know how much. So I'm going to use compatible numbers this time. Again, if it doesn't make sense to you, what can you also do? You can just start multiplying by 5 and then go up or down from there. But because this is close to 50, I'm going to try 50 and 350 or 400. What should we do? 350? Okay. So then how many times could 50 go into 350?
It goes in 300.
Think about 5 into 35.
I think the 35 goes in
7 times. So I'm going to try 56 times 7. And it's 392. Ooh, I'm just a little bit too high. So that means that 56 goes into 386 how many times? 6 times. Because right here, we just proved 56 times 7 is 392. That is too big. It's got to be 386 or less. It can't go over. We don't want to bust. So that means that I'm going to put a 6 up here in the top. And then 56 times 6, I actually have to like work that out now. See what I mean? My paper was covered in little bitty multiplication problems everywhere because I had to know what they equaled. So that's going to be 336. Then you do your subtraction part, which is just 50. And then B stands for bring down. And then you redivide. And again, I'm okay with you guys creating a new division problem so that that is easier for you to see. Okay, if I were to round both of these and use compatible numbers again, it'd be 50 and 500, but I know that I can't put a double digit up here. I can't write 10 up here. So what would be the most logical number to multiply 56 by? 9. Yeah. So I'm going to try 56 times 9. And it's 494. Will that work?
No. Wait.
It's got to be 502 or less, so yes, it does. I'm going to subtract 494. Wait, I did that wrong. 45, no, wait, what? Did I do that wrong?
Yeah, I got
56 times 9 is 54, and then 45.
Yeah,
Oh, it's 5. Ugh, that's why I'm like, something looks weird. Okay. Oh, it's too much. It's too much. Do you see? Okay, I mismultiplied. Gosh, guys, even I make mistakes. But I knew I was making, because it wasn't making sense. I was working ahead. I was thinking ahead. I'm like, this isn't going to work. Okay, and I had to go back and fix it. Okay, so do you see where I made a mistake? So this is 54. I carried my 5. And then here I was doing, for some reason I was doing 45 plus 4 to get 49. That's not right. 45 is 9 times 5. Plus 5 is 50. So that's too much. Too much just by 2. So that means that the 9 has to be an 8 because 9 is too much by 2. So we're going to do 56 times 8. And whatever we get is what we're going to subtract. 448. When I subtract that, I'm going to save you a little bit of time. It's going to be 54 left over as my remainder. These remainders look crazy, don't they?
Yeah.
Okay, we're going to make ourselves a little note here in the middle. Remainders will never be greater than the divisor. If it is, we made a mistake. And that's where my mind was going. That's how I realized I made a mistake. Okay, so if my remainder had been exactly 56, I made a mistake. It can't be the same as my divisor either. It's got to be less than the divisor. If you have more than what the divisor is as your remainder, somewhere we messed up, and the best thing to do is to probably just rework the problem. If you feel comfortable working backwards in your problem to figure out where your mistake is, that's okay. Sometimes it's just easier to rework it. Okay, we're going to do one more together. This time we're going to do the times 5 way instead of compatible numbers. And then I'm going to let you and your group try the last one together and we'll check it. Oh, goodness. Okay, 67. What do I put above the 2? A 0. What do I put above the 4? A 0. I don't know how many times 67 goes into 245 yet, but I'm going to try 67 times 5 because compatible numbers are confusing to me right now. And I'm just going to multiply this, which is 335. That is way too much, like way too much. But is it like where I need to do 67 times 2, or do we think maybe 67 times 3? Okay, so we'll try 67 times 3. I saw some head nods. We'll try this, 189. If I added 63 to that, do we think it might be too much? Do we need to try it? If I add 63 to that, y'all, this is literally what my paper looked like. I would just sit there and I would add or I would multiply. If I add another 63, it's like multiplying 63 times 4, okay? I don't want you to get confused. So if I do this, it's 252, which means it's too much. So it only goes in 3 times. It's all trial and error, guys.
63 times 3, not 67.
Oh, no. Y'all, wake me up. Give me another cup of coffee. What's wrong with me? Okay, let's try this again. 67 times 3. I love doing math. It's a good thing I love doing math. I can just redo it over and over and over. Okay, so that's 201. Now I know for a fact that 67 times 4 is going to be way too much. Okay, so 67 times 3 is 201. I'm going to subtract. And that leaves me with 44. Now I bring down and I divide all over again. So set up your problem again. Now I already know that 67 times 5 is 335. So that means that this is going to have to be what? Bigger or smaller than a 5? 67 times 5 is 335. I'm trying to get to 440. It probably needs to be bigger. So, but how much bigger? Do we want to try like 67 times 7, or do we want to try 67 times 6? What do we want to try? 67 times 6. Okay. Did I write it right this time? Good grief. Okay. So that's 402. Could I go again? Or is that as high as it'll go? If I did 67 times 7, would it be too much? It would be. Because if you take this and you added another, remember, multiplication is repeated addition. It'd be like adding another 67 to this. That would be 469, which is too much. That's too much for this. So it only goes in 6 times. It's 402. And then I subtract, and I have 38 as my remainder. 36, remainder 38. Okay, how many people, just a show of hands, how many people are probably going to try this by multiplying by 5 every time to figure out your number?
Me.
Well, that was me too. Okay, how many people like compatible numbers? Because you got to choose one. You can't not do one of them. You got to choose one. Okay, all right, I'm going to let your group, you and your group are going to work together to try number 4, and then we're going to check it together. So go through those steps.
Minus 42.